Good afternoon, gentle readers. Sunday, October 6th, 2024. From a desk with Ross Finlayson, here's today's moment and motion. Geometry is motion. Well, where it's at here in geometry is motion is that there's considered kind of the idea of how to approach mechanics when it's underdefined. Well, rest is rest, motion is motion, equal and opposite collisions. Force equals mass times acceleration. Gravity, it's a constant, inverse square, proportionally. That seems like kind of some positive definition, but it doesn't say anything about how does something start and go from 0 to 1 at all. Because mathematics doesn't even really have that. It takes infinitely many higher orders of change to explain even one thing goes from 0 to 1. So the infinitely many higher orders of acceleration, this thing. And then how I got started was figuring that, well, in all of physics and all of mechanics and physics and the wider theory, the unification of the theory, a sum of history is a sum of potentials, a gauge theory, a theory with conservation of conserved quantities, a geometric theory, a mathematical theory, of course. That is, insofar as geometry and mathematics are so together that physics is all these things at least. And then for mechanics, it's just kind of it's an extension of those, being that it's got to be a gauge theory and a field theory and have these continuities that make for these conservation laws. And with regards to form and proportion, the idea that the laws are the same everywhere, that there's a theory and not just arbitrarily, infinitely many different little lands of their own particular laws of physics. It's not just a good idea. Somehow it's one of these greatest ideas, the laws of physics, that is the wave mechanics is the milieu of this kind of thing. There's rays, the geometrical plainly, and waves. The development as of the most perfectly simple thing it could be is growing spherically, and then everything to do with that in terms of exchange and transfer and propagation and this kind of stuff. So we have fundamentally a wave model. And then, as was discussed quite a bit here, there's things to do with what about the vortex model, which is just with regards to a spiral and the in spiral or out spiral of Descartes or Kelvin, as with regards to that being a model of the mechanics. It's kind of like waves or particles, as with regards to our particles today. You say, well, our particle wave conceit of all quantum mechanics it has spin and angular momentum and all this stuff goes into it. So insofar as you might care, you can say those are vortexes and add them together. If you just got to make your own mathematics. And then as far as mathematical physics is concerned, once you've equipped a mathematical model that it so augments and equips a physical model of the theory, then it's part of it. So that's just one of these examples of one of these mental devices, a conceit, a concession of a theoretical element like an atomic particle. Can't really be seen to exist, except it's just kind of posited and deduced to exist, that it could as well have these other properties, and that it's not in the theory that way isn't necessarily because it's not so, although it's been picked up and put down, picked up and examined and put back down, and not brought into the theory. It's because the theory as it is this entirely tenuous connection, tenuous in the sense of from step to step, holding itself together bit by bit, piece by piece, to keep things all the way on down, as if for Hooke's law and Clausius Clapeyron and Lord Kelvin and Boltzmann and the second thermal law, making that this is kind of our classical thing, so that then our Bayes rule and the Hamiltonians on the mathematics sides are linear classical things. At least give one linear classical thing. So it's to be said that it's quite tenuous, this usual linear course. And there are many, many underexplored yet perfectly suitable avenues or venues of the mathematical models of the physics that simply have their own derivations and analysis, their own attachments to the thing. Then with regards to helping to thread that through with all the other parts of the derivations for the statistical ensemble to keep it coherent together, to say, well, like we have torsion as with regards to torque, as with regards to momentum going in angular, and it's all over the place. And then out comes something that was result of fictitious forces, however it so adds up and arrives to be. This after the ensemble, the statistical ensemble, and these usual ideas of electron physics as with regards to the mass and charge of the ratio of energy to mass of an electron and a hydrogen atom, or the hydrogen nucleus, and as with regards to those being kind of the quantities that arrive at electron physics in this quantum mechanical world, this atomic physics. That being then for all matters of this gives us mass and stoichiometry, and everything to do with mechanics is up above it. And is that's kind of the thing. So exploring the wave model then gets into lots of the descriptive aspects of waves, kind of like a graph, and the language of graph theory in mathematics has many descriptive terms that start to apply. And then when you can say something so for this kind of an object of one of these elementary accounts, then all the different relations that may so be about it are easy to deal with in terms of then in this natural language that it's like, well, you can observe that a graph that's completely connected has from any vertex a connection directly to each other vertex. So you can say that there's none without, or something like that. Or that if you remove one, that now there's one missing. Or if it's always a matter of the count of one, this combinatorial term the other, all automatically defined and derived from saying A, it's one of these things, and B, it's so this kind of a thing. Because it's not just like a kind of a thing standing by itself and alone. It's of all the relations it has to every other thing. It is a completely connected graph in the completely connected graph of completely connected graphs. In set theory, is there a universal set? Sometimes, in some theories. Is there a universal set in the usual set theory that we know and adhere to and love to an extent for its beauty and its aesthetic nature and its being part of this Platonic universe of good things, mathematics, or universal set theory? No, there is not. There is not. And there's what do we call that then? The set of all sets, the universe of sets. We call it a class. We call it a non-set. You know, it's still got a word. We call it a proper class or an ultimate class per quine or something like that. But there are other theories where it's like, is there a universal set? It's like, yeah, we're in it. Is there a universal graph? Yeah, and it's connected. Is there a universal group? It's like, yeah, and it's got an operation. There's an identity, you know, and these universals for particular structures are something that kind of go without saying and really run out of these things. Just like actual infinity is to simple linear classical finitist structures, just doesn't exist. It just doesn't exist, which is fine. And so then trying to figure that out is something, of course, that's been going on since antiquity. It's the practice of mathematics. How to get it back in. And then with regards to universalisms and these kinds of concepts of things, it's a thing. So waves and rays are pretty much a way to keep things fungible and sensible. And the ray is pretty much a straight line, but the idea that all the aspects of terms that describe it in geometry, they're kind of close to it. Then waves are kind of the richer part of it, because they say, well, we can get descriptive about waves and about their quantitative and qualitative aspects. They kind of have at least 3 parameters apiece, whereas a ray is like as few as if there are the dimensions of it, you know. in a world where there's an entire mathematical theory and an entire universe of mathematical objects is part of the theory. See, strong mathematical Platonism. So that was encountered trying to figure out these things with regards to that has to be a kind of a whole theory. It has to be the theory is kind of from whole cloth, and it's also as of the whole cloth of the thing. It doesn't really have another place to stand for this lever in Archimedes or that kind of thing. Yet as well, it's like Archimedes, you can stand wherever you want because the lever is a mathematical mental model of a machine. There's always room in Hilbert's infinite living working museum of mathematics. So these underexplored concepts that are still always bringing themselves back around, like the spiral or the vortex or the universe of the things, the context of the things, these come back around and help advise that we have a great standard linear way of things today, what is kind of called the candidate for foundations, and it applies to mathematics and logic and also to physics and science. There's also this fuller one that's been pretty much around forever that's still just kind of trying to creep back together its real form. Why it is so. And then that largely the challenge to appreciate that is to cultivate the deductive apparatus and to make it make it sure that the inductive by itself is not formally complete and cannot guarantee its own soundness, the inductive. Because you can point at Gödel's arguments and say, well, obviously it's only one of consistent and complete if it is good enough to make arithmetic, perforce, it would purport to do, inductive, forward inference. And at the same time, it's kind of like another way to look at it is like for every case you can build for forward induction, you can build a case for not forward induction. Which one you pick is, then it's just like you might as well just say whatever you want without regards to any kind of guarantee of induction offering. You're just making a case for it as by saying you wish it were so, stipulate it as so. So there's of course a very strong account why deductive inference is always kind of included, and it's got to be this very thorough and around reasoning. And after the fact, where it's like set up and it's like I can definitely see where I'm going according to this, all else held constant. It's got its own little modality there, its own little monotonicity in this way. The entailment is not otherwise independent. Then there's this whole wider modality, the more universal, where of course it's all got to kind of be reified this way, and there's a reification of sorts that gets into some technical terms. So I'd want to distance myself a little bit from the reification fallacy, or the veracity of reification. And the idea that any of these given structures that's built up so tenuously is this resistant metalling is just like putting in a box, shaking it up and pouring it out in any order. And then whatever possible stipulation comes out in whatever possible order is like, well, this is what you said. It doesn't really say when you said it. Vis-a-vis something along the lines of like, as it will come out, it won't really fall out all the way until it comes together, until its whole truth, its whole cloth kind of thing. That it's resistant to meddling in this sense, or it's as with regards to the more thoroughly organized, say. So that's what has been going on here. So how do we address the infinitely many higher orders of acceleration or motion? Because in mathematics, it's kind of given that the changes where this is, each of these is like a higher order of the definition of instantaneous change. Vis-a-vis, that's the derivative, say, vis-a-vis integrating it and saying how do we find out for all this what the distance actually is? That usually that's just like, well, it's whatever you arrived at. Take the average, take the mean of that, it's like, it's kind of this way. Or the finite element analysis, in as fine a grain as its terms as you'd like. That also works great. There's something to be said that it's just another finite element analysis this way and finite element analysis this way. But it ends up being one of those for every of the higher order dimensions, so it ends up being infinitely dimensional again. So there's of course all the usual ways to average or break down all these kinds of terms that come together that make sums, or estimates or sums, tallies or estimates or sums. But the actual infinitely many higher orders of acceleration themselves, underdefined. Then as far as that goes into the addition of velocities, and a bunch of other ideas came up here with regards to how to equip analysis with a thought experiment, a setup, an ansatz, a Gedanken, a theoretical device, an apparatus system to make for that these infinitely many higher orders of acceleration are built in. So first it's just kind of talking about like the big end and the little end of the series. Like there's only Zeno's geometric series. You get half and half and half again there. You infinitely divide infinitely many times the distance and the time and the terms, and it ends up adding up to 1. So that's like Zeno's geometric series, the classical exposition of continuous motion at all. And then it's kind of assigned to Zeno also. The Zeno swath is like, well, how does it get there in terms of like all these higher orders and back down through the lower orders, in terms of leaving from a spot and arriving at a spot. And so kind of going from rest through motion back to rest. Then that would include basically any other matters of dynamical change. Sometimes it's considered the simplest thing is like, well, how did it arrive right back where it started from? But the idea as well is like, it's like, that's the longest way to anywhere. In a sense, in that defining at least that much of it results in closure to define mathematically any other path or transit or travel over time. Whether that's going to happen and then be forgotten or remembered, 0 meters per second or infinity seconds per meter, or when it arrives back that it has gone infinity meters per second. That's not been introduced yet, but it's just helping to explain that in the terms, it would drop off or fall off to be that's where it would go if you let it add up. So we don't, because that's intractable, and it doesn't really end up being really sensible, although it's kind of arrived at be of its own fungibility of sorts. These kinds of things, big, bigger, and biggest, or big, biggest, and then bigger. These kinds of things with regards to infinity. So there's Zeno's swath. And then with regards to Zeno's swath, that was with regards to some of these other notions of this derivatives and integrals with regards to the dimensional analysis and the dimensionless analysis of the dimensioned analysis, and these reflecting on units, systems of units and units, and also the fact that a lot of what have become the dimensionless terms in the system are only after changes. So they build up this dimensional resonator and alternator to help affect to reflect that something like velocity measures the magnitude of relative motion and a direction. And then it can be added like with vector addition. Whereas speed is only the magnitude. It's like with respect to an arbitrarily larger frame, context to universe, the ground, a quantity, that the thing that ends up integrating into making this velocity in terms of all the integrations of all the acceleration and force as a function of time this way ends up being in terms of a 1.0 forward motion. So this dimensional alternator and resonator is both bulking up and down all the pieces, the resonator, and then the alternator is like canceling those out. They're constantly auto-canceling each other. So that it ends up arriving that a 363 turn both has taken a turn and is going in a direction the same. This is pretty clearly associated with, for example, in a finite element analysis and breaking that down into time steps. You can also break down these notions into these time steps. Or with regards to infinite series, that it would have to kind of live in these same terms. And then in the dimensional analysis that we usually have, it's like I'm entirely agnostic of anything to do algebraically with these mathematical model of above or below the divisor bar, these units, as long as they cancel and they don't have anything left to add up. This dimensional and dimensionless dimensioned dimensional alternator and dimensional resonator bit. So that's a pretty powerful concept. And I don't know where they have one in mathematics already, but there's a bunch of stuff that gets trying to figure that out, from the catenary to the line integral, from mechanics proper to all kinds of things like collocation of these items, sure, and a bunch of these other books and things that were mentioned. And without even getting into the usual ideas of, well, what's going on with wave mechanics, or how do we figure out just like the stationary solutions to these things, or these various progressive solutions to these things. It's like this is constantly adding up all this stuff up and canceling at the same time, so it doesn't have to keep track of everything, which nobody ever keeps track of, because it's not even a given into the formula. And for things that they're actually applying something to, it's either in a straight line, and so it also cancels, and it just has what it has left. And then the other way in richer and fuller things is you got finite and element analysis, and increase the step size or decrease the step size, increase the grid finery and decrease the step size. This is the way that these things are just given to add up when they do. And then otherwise it gets into all these jumps from context to context, like in general relativity. Like if that's from quantum mechanics, this is outside, and then in general relativity, it's like we just have two systems of coordinates. Great. They're connected by these tensors. Fantastic. So they just add up, and you just do vector addition right over these tensors, coordinate system. Yes. It's coordinate free. You don't even have to care. Fine. So how these tensors work? They just have to do that. As long as they are what they are and what they do, then they add up to that. It's like, oh, so do we have mathematics that just kind of gives these? And it's like, no, you have to build your own for each particular contrivance of solution. So if you have like a gauge theory, you have to like build in all this Rindler's road to reality with Penrose and make a thing that keeps us together. Or like you need Hermann and Jet bundles because he helps you comprise boost addition in problems in general relativity, like from Messiah or something like that. We can really get into, all the necessary complement of the accoutrement, what's otherwise vector addition for our addition formula, if we're going to have something that keeps the geodesic in one piece. So it's missing is kind of what I'm saying, and it's kind of contrived, and it's just is what it is. It is whatever adds up, so it's still good. The theory is still good. It's underdefined. So we got mechanics is underdefined. We got motion is underdefined. We got that's true in the large theories and the small theories. All right, and it's true in the middle. So there is perceived that's how the way things should be understood, is to augment them with these various motions of the notions, or notions of the motions rather. moment in motion for this true static torque, true centrifugal, and stuff like that, with regards to otherwise the regime of the centripetal and centrifugal in their exchange, and the regime of torque and dynamics in the exchange, and the angular moment as of about torque and torsion. The angular is the kinematic here in this setting, and the linear and rectilinear is the kinetic in this setting. And then with regards to temperature, and that being like, well, it's kinetic, just bouncing back and forth. That's split out as like the low energy and the low end. And then with regards to light and the optical as being geometric rays, it's kind of let out to the high end. Motion and moment. So that was brought up in here about the infinitely many hierarchies of acceleration, Zeno's swath, the dimensional and dimensionless alternator and resonator, and then as with regards to some more of these mathematical concepts intended to find similar matching concepts in the Hilbert's Infinite Living Working Museum of Mathematics, so that then you can find people who've already solved all these kinds of things and help keep them together and reinvigorate them and revitalize them. So that's one aspect of the going on. And I don't know so much about it. I mean, it's like when reading about the collocation book here, it's like, well, this is great. Somebody has actually tried to put this next piece of the aspects of the things together, the hypercube distance. Because otherwise, I'd be wondering why they haven't thunked this up in their head, and why it hasn't been thunk up in the great big collective head of everybody. So the hypercube distance is this kind of idea of that from a beginning to end, there's any number of parameters or variations. What it results is a straight line between 0 and 1. So the question is, what is the length of the diagonal or edge of the hypercube? What is the hypercube distance? Well, it's 1. Well, how does it get there? It's like, it's however many dimensions of the hypercube there are, where the property of this hypercube distance is this. The hypercube starts as an n-dimensional, infinite dimensional hypercube of arbitrary side lengths, and then as with regards to a given time 0 to a given time 1, it starts as from the little end of the geometric series, and it starts with the highest order of acceleration, see, and then collapses down to the lowest order of acceleration or displacement, so that the distance is 1, and then it just does that in a kind of in inverse or reverse Zeno's geometric series. So it's given as another kind of paradoxical thing, because just like Zeno's other thought experiments, they're often phrased as paradoxes. They can't be, because they also define exactly what we observe a motion to be. Nobody ever observes Zeno being wrong about his setups. They must be so, because there's also deductively reasoning why they must be so. If I had to bring one of those, it would be according to geometry's motion in this longer kind of bit. But everybody knows the classical exposition of Zeno's motion and why things are like so, and the gives and takes and how it would be perceived as a paradox, and there needs to be some reason why it's not. So these other ideas in the higher order of this, of continuous motion, are also just kind of set up as more of Zeno's arguments. Apocryphally, after Zeno's usual arguments, and then Zeno's graduation course of the runners back and forth in the halving and doubling spaces, where it's kind of like, furthermore, we can start to see that our mathematics add up. It is hard to compute how fast the bees flies back and forth between two oncoming trains, if you've heard of that one. Zeno's graduation course. Then apocryphally, there was like another dozen or 2 dozen of Zeno's arguments. And we're not sure, I don't know if they were profound or if they were mundane. So it's with these other ones that's being kind of associated, that's all this higher orders of acceleration, the swath going around the side, this hypercube distance coming down, that these are the kinds of things that would be more of like what happens, because then to say is like, well, does that add up to any particular example of a case of motion? It still does, yes. Insofar as it's got 0, 1 in length and 0, 1 in time, and 0, 1 in whatever and however the turtle goes from point A to point B. It is like so. Like, for example, if you were programming a turtle in the language of Logo on the computer screen according to its procedural instructions, and you had to give it infinitely many to make it so to add up that it went from 0 to 1, it's as well so modeled by this idea of the hypercube distance. So that's the thing. And then, yeah, and right before that was kind of mentioned the Zeno swath. So the Zeno swath is kind of like, well, for some particular cases of that, like just like it's just taking the diagonal. And so it's like, kind of like instead of a path integral where all the paths are as of a wave, that is taking the path integral that all the paths are as of a triangular wave. So it's, instead of being like a sinusoidal, it's triangular, this Zeno swath. And the reason why is because it's always ever only of like a box in like all the greater space of the thing, as opposed to like a particle, which is like, well, as a wave, it kind of has an extent given by that, according to the event, it can only have traveled so far as by its time that a particle could arrive. This is the complement to what's called Heisenberg's uncertainty, which is that momentum and position are inversely fine. That if you can know that one of them is so, then the other one is, its uncertainty is raised. But that Heisenberg's certainty is still that it's like, according to this laser rangefinder, according to the distance and according to the speed of light, it's perfectly defined when it arrives, and it is according to what energy it has, what momentum it has, that it's could be kept in mind. The uncertainty can be vanishing small, besides that it's asymptotically free, the Heisenberg uncertainty. Which is just kind of like, well, because otherwise you could add up that the things wouldn't add up. This is just one of these examples of already in the theory is like, this is where it's let out to be this way, so it's overdefined in a sense. Well, it's still profound, and asymptotic freedom is a great and necessary concept to understand after particle wave duality, asymptotic freedom, and then this Heisenberg uncertainty is more of this. Asymptotic freedom is for the Quarkian physics and the subatomic physics and what holds it all together. For otherwise, wouldn't it just be altogether a thing? Yeah. So yeah, waves, then the infinitely many higher orders of acceleration, Nessie's hump and such, which is a case for rest exchange momentum, because now momentum is no longer exactly the same linear quantity that is classically, and it has been for a year, a century or two, since when Wallace and the formalism came up for the linear, particularly for the statistical ensemble and the standard definition of the day, the matrix. After the great profound divide between the Leibnizians and the Newtonians about V matrix and V viva, the forces of motion in the matrix and rectilinear, and V viva are this active force, that it remains that the motion of the momentum that it travels is not really conserved. Like, really, it's the energy it's conserved, because that's a conserved quantity, where momentum is supposed to be this overall outcome of force. When is, if you drop something to the floor and it bounces until it comes to a stop, was there any left? Did it really just what did it do? Did it just bounce off in a gravitational wave at the end? Is it sound emitting it, or otherwise it's just, did it go to, it's basically breaking the ball as it bounces. You see, this just goes to give another example of an experiment where it's like, yeah, momentum is conserved in the open here. So that helps explain why it's kind of localized this way. And obviously, then it would need an explanation to help explain where it went and how it comes back. Because on the outside of these systems, after what are not perfect inelastic collisions, when there are perfect inelastic collisions, where it looks perfectly it's like it's conserved. But you could just as well say that the energy was conserved. It's bounced and reflected off that immovable object did move. Or else, it did give. Or else it didn't, and then it's perfect and geometrical. And optical here as it is, with the phase and reflection and all this kind of stuff. So there's been a winding up. Winding up quite a bit of development of a deconstructive account of the formalisms of mechanics, from the small quantum mechanics to the large cosmological, classical mechanics. All these things that go into both a historical account and a formal account, more specifically a formal account for mathematical treatment of a mathematical model, make a physical model, when it's still so that our classical model has this reason. It helps to explain also that it's not what's wrong so much as what's missing. And so what ends up being undefined and underdefined, it hasn't so much resulted to have been something being done wrongly, as that there's a way that it's more thoroughly defined that arrives to be done more rightly, less wrongly, if at all. So the hypercube distance and Zeno's swath, and these getting closer to helping to explain something like, well, then let's bring in Descartes' model of vortices and Kelvin's models of vortices to help explain for billiard ball mechanics that they're rolling and then just only moving at the instantaneous collision, yet still always rolling, sliding, and twisting, and orbiting each other. That is in the round and the surrounds. That's how it really all falls down. That then it gets back to then just and also as well we can just consider this with regards to kind of like the locality of these interactions of peace. Besides the statistical ensemble, is like we're in the middle of a giant cloud of these atoms bouncing off each other and trying to figure out whether from their Hookean dumbbells or otherwise how they lever off each other. Each one of those a piece, then adding up over the whole field of this gas to adding up with a formula that makes up for why this is kept. And it's like the Lagrange has kept this for everybody sane, and because otherwise everybody would be at a big huge loss. They'd just be like, I agree with Lagrange, that it would be so. These are the kinds of things then it was like how to figure out. It's like this addition in the local of each one of these then is still going to figure out for that being then still the classical mechanical part, vis-a-vis otherwise the fluid models of electricity and magnetism, or fluids in the state of matter, or gases as both superfluid and also compressible, and solids is definitely not superfluid and also not compressible. or vis-a-vis how then that has also, just for examples, in solids, the piezoelectric and all this kind of stuff, or in liquids, then they have the true superfluid, like in particular regimes of gases in the very, very cold, or liquids in of the very particular properties, solvents, and these things with regards to properties of the systems of the substances, according to their surfaces and their volumes, the aerial terms. All mechanics, all physics of all the known fields, which I know is ambitious, yet that's what we're talking about going into what is the thing. And we know still today that there are empirical effects. Anything that's called an effect is not in the theory yet today. It's not yet in. So, trying to figure out how to help get some more of that stuff in, while our theory is still the same, involves the definitions that's of what's underdefined, in some cases what's overdefined. That what's underdefined makes for this infinitary reasoning. That's the only thing that's really left to add up is like we did you a great solid favor and kept infinity out of physics for about hundreds of years. Now, at some point in time, it's got to come in. So you kind of probably want to have a pretty measured and structured approach to that. As with regards to otherwise than what's overdefined, perhaps, it's like here we just picked this formula because we noticed that it always added up. So if you don't like that one, maybe you should feel that you should know that that's just there because that was just filled in after the fact. Now that's not always so, but it's just with regards mostly these doubling and halving measures with regards to Clausius and Boltzmann and some of these things. Why 1/2 or why is that extra 2 in that formula? Is that sometimes it's like it's arbitrary. So we just kind of fudge and says, well, we're integrating anyways, so we'll just call it part of our constant. And it's kind of like, well, it's a pretty big constant because that constant could arbitrarily be 0. The constant integration is not necessarily non-zero. I tend to think it's 0. And there's a particularly large class of integrals. It's constant integration, 0. So this is ranging pretty farther, but it gets into stuff about with regards to the definitions of analysis, the definitions of mathematics, for the definitions of physics. All the same ones we already have, and then finding where they're simply not defined. They've been left that way. And then figuring out what goes into these Newton's zeroth laws. So that's kind of what's been going on here. And this was just kind of a bit of a survey to help kind of convey what is going on with this, just in case it didn't really seem to be coming across as that there are these developments perceived to be in effect. And then all these different inspirations in these readings have been gathering a lot of these different pieces, pointing to a lot of these different displays in the Hilbert's Infinite Living Working Museum of Mathematics. When such is the case that there are these underdefined terms in mechanics itself. And all of the historians of science know this. And many or most of the practitioners in the field do not. So for theory's sake, it must be that there's some kind of improvement in regards to this, that here it's framed with regards to first formally accepting that there are infinitely many higher orders of acceleration. And then that's only at least just, another schema of the finite element analysis again, but it's at least one other entire schema. And it does introduce infinitary reasoning. That will be how I will kind of try to figure out to approach mechanics in this manner for the theory overall. In mathematics and theory, I already have a lot of stuff that's kind of built up. It's like the course is infinitary reasoning. There's at least 5 definitions of continuous domain, which I've extracted from the canon largely and just kind of pasted together and found some tiny bridge glue results to keep them on the same boat. But then for mechanics in this moment in motion, that's its own kind of thing. So let's take a look briefly at something from the ancient Greeks. All right, there's an Anaximander, because there's like these notions of the 5 elements: earth, air, fire, water, and then substance or the ether or space. The Pythagorizers, the Epicurides. Oh my gosh. Antiphonys he says these terrible things about Pythagoreans, as in setting up the fallacy of the straw man or something like that, or I forget which one it was. It's like, did you hear about Uncle Louis? It's like, what is like Albert Einstein, or something like that. I forget exactly what it was, but about beings and Pythagoras. So this is less the technical. No part of the universe is empty. Whence then might anything come? So the idea of this universe is not being empty is also that anything that's in it is all the relations in it. It's completely connected. So from whence does it come? It's like it gives. It's like a structure that's entirely, completely connected. It might be considered that's vacuous or tenuous. But at the same time, it's like, well, if you're going to go that way, then the next thing that happens is there's an integer continuum and then a linear continuum. And then a long line continuum. And then 3 space dimensions just kind of unfold from that and tent up, and that's it. All according to this ray of time. Also the same mathematical structure and resource, a linear continuum. And then as far as anything else goes that builds state as models of change, and that is space-time. So for Aristotle, because otherwise Aristotle is just saying, let me ask you this question, because I'm going to frame it to you that this way we won't let it be so introduced to otherwise affect what otherwise would bring up as stipulations and axiom and syllogism, so that they can just kind of be considered to be abstract and fantastical, and that they did arrive as from nothing in this universe, without necessarily the whole kit of this entire strong mathematical Platonism's account of axiomless natural deductions, axiomless geometries. But the sound of the millet seed, Zeno, and this we kind of looked through this before, and as with regards to the Zenonian arguments, and those being the classical expositions of time. Well, here are some books I gathered. So this fella, this is Gregory Bateson. So he was he's an anthropologist from like the 1900s he was born about 1900 through like 1975 or something like that. And so what you find is that he's got a lot of influential things about anthropology and with regards to psychology, and the study of social sciences and putting social sciences in some kind of scientific setting. And one thing about that is it's just too difficult to do that sometimes with the social science and the scientific setting, because subjects in such studies are as well elements of the society. So it's basically impossible for it to not affect itself. It's got its own problems, but otherwise it's very readable, very very valuable, and you get some stuff like national character and stuff like that. This is Joseph Campbell's history of this is a pretty good history of Earth in terms of since the times of the Sumerians and the Egyptians and the development of their ideas. And so this is called the Masks of God, Oriental mythology. And what it gets into, so it's not so much about like the Hellenistic and the Roman and the Levantine or the Mediterranean or the Near East, or the here in this book it's framed that the oldest culture and civilization was the Sumerians and Akkadians, and then it became the Aramaics, and then you got the Egyptians on the side because around the Nubians. Because there's this kind of great desert of the world that goes like from the Sahara and then points through the Rub al-Khali and then just goes across and then kind of lands over in the Gobi Desert and then comes back around out the other side or what. And so with regards to something like that, it's like there's a history about up to 4,500 years ago, and then with regards to when the current or most recent flood was, or the antediluvian, whether that was like 2,500 years ago or the various counts of timing. Or as with regards to the Nubians, that the Nubians were around at least 6,000 or 7,000 years ago, and what became of them? Or as with regards as well to something like the Indics, then, because it's kind of like the Sumerians and the Akkadians were the first thing that built up since like there was society and civilization again, whether it's with regards to the previous cycle or what, and the Indics, that it's still the Indics, and whether the Upanishads and the Vedics were still the oldest tradition that we still have might so be the case. That then there's the notions of the universal mother of Homo sapiens in Africa, and then as well as with regards to 4 or 8 or 10 different sorts of pools that developed in the hominids hundreds and hundreds and thousands of years ago, which resulted in particulars that came of like the Mongols or the second peoples, not the Indics that peopled Southeast Asia, or the 85 tribes of Africans. That's where generally the most genetic diversity arrives is from Africa itself. Or the besides the Caucasoids and stuff like that, like the kind of the northern sphere, and then the central and the middle, kind of like with regards to that being history. So then otherwise it gets into like with regards to all of what's recorded in history, it kind of puts it in one book how I arrived at that, which is nice. This is about the Dead Sea Scrolls. This is about the Sufis. And this is also about the Dead Sea Scrolls. So this Miller Burroughs book was like when the Dead Sea Scrolls were first discovered, which is like, wow, we found a bunch of writings from the time of 2000. And it's like, well, if the Chinese burned all their books in the year 500 and after the Shang or whatever, that's just an example, or like the Library of Alexandria, it's gone. And all this stuff, and all we got left is some fragments of Aristotle. So when they found the Dead Sea Scrolls, it's outside of Jericho. So it's not really necessarily, although it's largely expected to be understood as that it's Hebraical, that then also has to do with the Romans and the Hellenes, and then also with the east of that, like not just the Essenes, but also with regards to the Alexander's and Darius's Persian Empire and all that stuff that was in the middle, and as with regards to the kind of concomitant launches of Buddhism and Christianity. And then after that, Golb is like follows on to that. He's an academic researcher in the Dead Sea Scrolls. Helped them figure out, it's like, well, were they just the Essenes, or Is it so that the Qumranic camps were all just libraries, or they were just getting their hiding places after the great civil war of the time of 60 to 75 AD, and then who's who and what's what, and what does it really say, and are they the same or different than what we have today? And the Sufis helps explain kind of the Sufi approach to things, but there's like internal and external Sufis, so these aren't necessarily the same ones that you'd hear about, because there's kind of the Sufis, and then there's like the Farsis, and the in terms of the, on the one hand there's Sufis, but on the other hand that there's kind of like the ascetic Farsis. So kind of like the Essenes would be kind of like ascetic and monkish sect. Then in the Sufis there are also sects and sects, and in, just like in other religions there are various sects of various considerations as regards to like materialism and honor, and with regards to things like reputation, or getting along to go along, or going with the flow, or going with the herd, or going with the crowd, or looking out for the herd, or looking out for the crowd, or being an individual, and all these kinds of things that have different things. So the Sufis have this is more of a modern approach. That my attachment to Sufism is a little bit different than it. And then this Kessler is an essay on man, so maybe we'll take a moment, look at this then. So that being just some historical things to help reflect that these aren't so much the technical then, with regards to the technical philosophy, except as with regards to pretty much that they're not. So I've read these. This is by Carl Jung. He's a psychiatrist, and so as a psychiatrist and a psychologist, he interpreted dreams. And I started to read this, and it's sort of an autobiography. So when he was like 80 or 90 years old, he kind of has this biographer amanuensis, and he starts to recount some of his stories of his childhood, and about how he's come to develop, and his theory, and as with regards to Jung and Jungian philosophy of psychology and psychiatry. Then again, I was intensely interested in everything Egyptian and Babylonian, and would have liked best to be an archaeologist. But I had no money to study anywhere except in Basel, and in Basel there was no teacher. So this plan. My father. In spite of my growing scientific interests, I turned back from time to time to my philosophical books. See here, there's a philosophy of science. And so science isn't merely technical knowledge and know-how. And it's definitely not stuff like, well, in my app, I get some points by icon and the emoji with the time of day according to whether my points are worthy or what. I mean, that is a science, because it's basically a brainless zone of a ruleless thing, and it's only just trying to make sense of a front end to what's really just a kind of a babble of things. So it is a science, but it's not really a structured science. Their structured science also has a philosophy of structured science, as with regards to it is and how it is, that the philosophy then is eventually entirely profound as with respect to the science. That you can't be having a science without philosophy, or the whole great thing out of scientism and Comte's logicisms and strong logical positivisms, Boole's, Russell's, Popper's, scientisms. Science is that it's empirical without a philosophy of science. Undefined? No, philosophy brings a great body of definition right to it. So this is this is stories of his patients, and his work as a psychotherapist. Drawing the mandalas. When I began drawing the mandalas, I saw that everything, all the paths I'd been following, all the steps I'd taken, were leading back to a single point, namely to the midpoint. It became increasingly plain to me that the mandala is the center. It is the exponent of all paths. It is the path to the center, to individuation. Now, individuation is its own kind of thing, and we got individual, the continuum, and then we got individual in the social setting, and when it's with regards to individual liberty is why America is, when we're like, well, individual liberties were part of the parcel of the founding of this great democratic experiment for the first time in history. Everything else before that was like the order of society and the role you're cast. And it's like, this is not that place. And indeed, these days that's spread around the world, and it's called universal human rights. So anyways, lots of these studies of from memories, dreams, and reflections, confrontation with the unconscious of Carl Jung does have import to the dialectic of this. And then we have some other things to get into here. We'll get into maybe some more next time. With regards to Ernst Cassirer's An Essay on Man, Alan Franklin's No Easy Answers, which has got some interesting things about kind of the modern scientific setting, and by practicing academic and research physicists, and Philosophical Hermeneutics by Hans-Georg Gadamer, where hermeneutics is basically this idea of the theory for itself and all contained. Well, gentle readers, I shall so wish you have a great day.